The Vevo Laser X system is a unique multimodality imaging system combining ultra-high frequency ultrasound and photoacoustics to gather anatomical, functional, and molecular information from just one image acquisition. This short demo shows just how user-friendly this compact and flexible platform is for brain imaging. For setup, the mouse imaging platform incorporates a highly innovative stereotactic frame. This allows the head to be fixed in place for straightforward and reproducible brain imaging. The Vevo Laser X is fully customizable for your research. Here we recommend the MX201 transducer at a central frequency of 15 MHz. This, in combination with the narrow optical fiber, will allow deeper brain imaging through intact skin and the skull. For improved workflows, we have also incorporated a neuroanatomical reference into our Vevo Lab software. This brain atlas ensures that you know which area of the brain is generating the signal. The touchscreen user-friendly interface makes it very easy and intuitive to navigate through the system. It's just like using your smartphone. On startup, you can customize the software interface. Each user can have their own account with their personal settings. Here, we're starting to visualize the blood flow in ultrasound Doppler mode. This is the functional information about the blood vessels, so together with B mode, we can visualize the anatomical information and assess the degree of vascularization, either in the whole brain or in specific areas, in both 2D and 3D. For example, if you are imaging a tumor, you can access angiogenesis and follow its behavior over time. Moving into photoacoustic mode means you can determine molecular parameters such as hemoglobin concentration and the average oxygen saturation. By selecting a single wavelength, we can detect the endogenous contrast, which comes from the blood and other tissue chromophores. Setting the laser to oxygen saturation imaging mode creates a parametric map showing the average oxygen saturation of the brain tissues. Red areas indicate highly oxygenated tissue. Blue shows the more hypoxic regions. This can also be done in 3D, allowing the degree of oxygen and hemoglobin saturation to be calculated across the whole brain. In preclinical research, it's important to generate quantifiable results, and the Vevo Laser X, with its ultra-high frequency ultrasound and photoacoustic imaging, allows for quick, simple, reproducible, and reliable examinations, generating data to feed into this phase. A typical application for this technique is imaging hypoxic or ischemic stroke models. The mouse is under gas anesthesia with a mixture of oxygen and isoflurane. An oxygen challenge is created by switching the gas supply from medical air at 21% oxygen to 5% oxygen for a few seconds before switching back to medical air. You can see how the parametric map changes from red to blue under hypoxic conditions. For quantification, regions of interest can be selected and a graph generated with time on the x-axis and average percentage oxygen saturation on the y-axis. This shows the drop in oxygenation during hypoxia and the increase of oxygen returning to normoxia. In addition to the oxygen saturation, we can also measure the hemoglobin content. Here, the color parametric map shows the total hemoglobin content in the brain, allowing visualization of, for example, regions of hemorrhage. So, photoacoustic imaging and ultrasound allows optical signals to be detected, resulting in exceptionally high resolution and quantification. The examination is quick, it doesn't use any contrast agents, and is non-invasive, so you don't have to sacrifice the animal. Other research applications include investigations into blood-brain barrier disruption and drug delivery across the blood-brain barrier using dyes and nanoparticles combined with focused ultrasound disruption. I hope this demo has given you a good overview of how quick and easy it is to study the brain, and also to show you how the Vevo Laser X system can be used for a huge range of additional research applications. A growing number of leading European institutes are now using the Vevo Laser X. If you're interested in finding out more about the technology, applications, and literature, then please visit our website and get in touch. Thank you for watching, and we look forward to hearing from you.